Now, in physics, you might be asking yourself the question, what is significant figures? And this here is going to be important first looking at a question that is going to be given to you. The question here says that, hey, we know this formula to be E equals mc squared, the one of physics equations that is introduced by Albert Einstein, where E means the rest energy of an object and m is the rest mass of the same object. Now, in addition, c symbolizes the speed of light, which is in a vacuum, which is equal to 2.9979245 times 10 to the power of 8 meters per second. Now, the question here says that you should find the energy of an electron in joules. And so, based on this, there are a couple of concepts that you should be aware of. And one is, what is significant figures? Second is, based on that, what are the operations that are required when dealing with decimal numbers? And these operations will include addition, subtraction, multiplication, and division. And next here is focusing specifically on multiplication of numbers, because that is where the original question comes from. And now, looking at the significant figures segment, there are a couple of concepts that we're going to touch on here. First is we're going to express accuracy. What does that mean? And next is going to be focusing on what is uncertainty versus error. Are they the same? Are they different? And next here is going to be looking at the percent error, and finally here is going to be dealing with significant figures. Now, when we are looking at the expressing accuracy segment, what does this mean? This means here that when measuring an object, how close is the measurement of the object to the correct or true value? And this here is shown in two ways. One is uncertain with error, or the other way is by using percent, or some people call it fractional error. Now, let's look at uncertainty with error. And this here, uncertainty with error, is pretty much the same thing as error, spoiler alert. And this here is the difference between what? The measurement taken from an instrument from another instrument of the same object. And this here, for example, focusing on a ruler versus a caliper. And this here is used in this case when measuring the thickness of a phone like this. You might be asking yourself, what is the thickness of the phone when you use a ruler? This here gives you just 2 millimeters. However, when you use a caliper, we actually get values to be 1.95 millimeters. And then you might ask yourself, why are there much differences or any difference between these two values and also the instrument? And this here, looking at it, comes down to uncertainty, and this here focuses on first that the ruler is reliable to the nearest 1 millimeters, because of course it's just 2 millimeters, and this here is considered to be a higher uncertainty because we don't really know how close it is to the true value when we have the numbers after the decimal point. But on the other side here, or digits after the decimal point, but for the clipper, we have it to be reliable to the nearest 100. So this here has a smaller uncertainty, which means that it's getting closer to the true value. And so, looking at the next part here, which is how to write accuracy, which is for the first step or method, this here can be written as the following. First, you have the first value, and then it's followed by a plus or minus symbol, and then we have the second value. And what does this mean? The first value means the mean value, that is pretty much the middle number, and the second value is the measurement of the uncertainty. Now, let's take an example here. The example here says that the radius of a cylinder is 39.337 plus or minus 0.05 millimeters. What does this mean? This means that the true value is in the range of what? the actual mean value plus the measurement of CA, which is the 0.05 millimeters, which gives us 39.42 millimeters, to the other extreme range, which is the mean value minus 0.05 millimeters, and this here gives us a 39.32 millimeters. So these here are the range from this particular expression for the radius of a cylinder. Now, still focusing on significant figures, we're going to be looking at the next part, which is percent error. And what does this mean in terms of how we're going to write it accuracy wise? In here for method 2, we are going to be writing percent error as the following, where the first value is going to be plus or minus the second value, where the first value is equal to the mean value, and then the second value is a measurement on CA in percent. And what does this mean? Let's take, for example, here we have the temperature of the human body to be around 37 degrees Celsius plus or minus 5%. This means here that the true value is in the range from the 37 degrees Celsius times 1.05, because you're adding 100% of that value, which is pretty much the same value, to that of the 5% of the 37 degrees Celsius, and this here gives us 38.85 degrees Celsius, to the lower end here of the temperature, which is 37 degrees Celsius times 0.95, which is taking away 5% from 100%, and this here is going to give us 35.15 degrees Celsius. Now this here will lead us to the final step of our significant figures, which is actually, of course, spoiler alert, significant figures. And what does this mean here? This here means that these are important digits that are present in a number. And this here, looking at an example, is what does the number 45.83 centimeters mean? This here actually means first that the total significant figures that are here is 4. And next thing to keep in mind is what are the true values, which in this case the true values are the following: 45.8, and that is the true value of the length of that object. But then what is 3? 3 significance here comes into play, where we recognize that it is positioned at the 100th, and it is the last digit here after the decimal point, which makes it to be an uncertain digit here. So in this case here, we're going to look at all the examples of significant figures in terms of what the following: how many significant digits are in the following numbers. Like in this case here, we have 356 minutes. Next here is we're going to look at is 0.35 minutes. We're going to look at 0.350 minutes, and next is we're going to look at 0.0350 minutes. When it comes to the answer, first, for the first question here, the answer here is 3 significant figures, because all these numbers are non-zeros and this here is a whole number. Now the next one here is what? 2 significant figures. The reason why is because after the decimal point, all the digits are what? They are non-zero digits, and there is no 0 after that. So that means we just have 3, 5 as the 2 significant figures present here. Next is that, how about this here? This here shows us to be 3 significant figures, because that 0 counts as an uncertain figure or digit here, which makes it significant here. Therefore in total we have 3. And finally, what do you think this is going to be? 0.0350. Is this 0 significant or not significant? And voila, this 0 here is not significant. So any 0 that is immediately after the decimal point, those zeros don't count until the very first non-zero digit shows up, and then all the other zeros that comes after that counts. And so in this case here, we still have 3 significant figures. So now you have a little bit of an understanding on how to count significant figures in a number. We're going to apply this to operations with significant figures, and here we're going to explore the rules on the following. First, we're going to look at addition and subtraction. The rule that applies to this here implies the following: that we are going to pick the number that is what with the highest uncertainty. And what does this mean here? This means that it is the last digit to the right of the decimal point. So keep that in mind for the next examples that we'll be looking at here. And next here is looking at multiplication and division of numbers. Here the rule states that we must pick the factor with the least significant figures. And now let's look at addition and subtraction. Example here, we're asked in this question here to solve the following, where we are going to be adding this particular decimal number to this decimal number, and our result we're going to minus this decimal number. What do we notice here? First is, when you're adding and subtracting, we need to remember what the rule for addition and subtraction says. The rule states that the number that has the least number of significant digits after the decimal point is what we're looking for. This here has 3 significant digits after the decimal point. This here has 1. This here has 2. But in this case here, we're going to use this here as our model for how our final answer is going to look like, which means it's going to have 1, because in here the digit 1 is placed at the 10th place, and therefore it means that when we solve this question, we are going to have our final answer to be 0.6, not 0.584, and so on. So take note also that in terms of rounding, we have 8 to be greater than 5. That means that 8 is going to transfer 1 over to the 5, and that makes it 6, and then the other digits after that number are going to be thrown off here. Therefore we have this to be our final answer. Now let's look at the other part here, which is for multiplication and division. But here we're going to have 2 examples. The first example here is going to be looking at what, when we just have this particular multiplication here, where we have the numerator multiplied together and divided by the denominator. What does this mean here in terms of multiplication and division? The rule, remember, states that the number with the least significant figures overall counts as the actual result, how it's going to look like. And therefore here, when we look closely, we have this number here to have just 3 significant figures. This here has 2 significant figures, and this here has how many? 4 significant figures. Therefore our answer should look more like this here. And so when we type this on your calculator, you should have your final answer after you round to be what? Just 2 significant figures. So that means our 7 here is going to be, of course, greater than 5, which means it's going to be adding 1 to the 7, which makes this to be 8 as shown right here, and then the other digits after the 7 are going to be thrown away. Therefore we have our answer to be 0.48. Now let's look at part 2 of multiplication and division, and I want to encourage you to try this one here. And this here is a little bit tricky because you're looking now at scientific notation, and we have 10 to the power of 6 multiplied by 10 to the power of -4, and you have this number here to be multiplied by this number. But we want to what? Think about which of these 2 numbers have the lowest significant figures overall. Now what we can see, of course, is that this has 3 significant digits, how this here has 1, 2, 3, 4, 5, 6 significant digits. Therefore our answer is going to look, after the solution, to be this right here, which is what? This particular number, 2.97 times 10 to the power of 3. Now looking at this, we're going to go back to our original question to now see how we're going to solve the question which is stated as this, and there are a couple of variables that we need to search for, like what is the mass of an electron. In here we know that the mass of an electron is what, 9.11 times 10 to the power of negative 31 kilograms, and we know according to this question that the c represents what, the speed of light in a vacuum, to be around this number times 10 to the power of 8. This is quite a long list of digits, and so what we're just going to do is just put them all into the equation. We know that we're going to be multiplying this here, our mass, by the square of the speed of light, and that will give us the energy. And once we do this, we are going to take the action here, which is by solving for what the E and the energy is. Keep the base, solve the exponent, and then remember that of course we have the squared applied to the 8, so that means we're going to have 16, because we have 2 times 8, which gives you 16. That shows up right here as the exponent. We have the same base but different exponents. That means you keep the base and you add the exponent, which means we have negative 31 plus 16, and we have our units to be kilograms, meter per second, all squared. But remember here that this number here, 9.11, is going multiplied by the what? The squared of what? 2.99792458. And so we arrive at this. We just move the decimal point one step to the left, and then our final answer is going to set up in this particular manner to be 8.19. And why are we picking 3 significant digits here? We're picking 3 significant digits because our question, when we search for the electron's mass, is given in 3 significant figures, and therefore this here is our final answer, 8.19 times 10 to the power of negative 14 joules as our answer. So I hope you found this really informative in terms of how to use significant figures, in terms of not only adding and subtracting but also multiplication and division, and how we applied it to this particular question. Please remember how significant figures works, not only in terms of counting them, but how they are important in terms of how uncertain some measurements can be and tools when provided. I hope you found this really informative. Go down to the comment section and let me know your thought about this. By that way, we can talk to you soon. Stay smart as always and believe in yourselves.